All right, section 8.1 video, part 1. This section will probably have 2 parts to it. And what we're going to look at in this particular section is we're going to look at solving quadratic equations. And notice I set up here again. Now you don't have to copy this down right here if you don't want to, but if you want to copy the title, pause it and copy the title. But anyway, so first of all, let me remind you of what a quadratic equation was. Last video, we ran into 2 quadratic equations. Remember, a quadratic equation means that you got the highest, it's a second degree polynomial equation is basically what a quadratic equation is. Now, how do we solve that? We learned how to do that in 5.8. Number 1, it has to be set to 0. Number 2, you have to be able to factor it. Number 3, you set each one of them equal to 0 and solve it. But if you've got your notes handy, if you flip back to 5.8, we did about 10 or 12 examples in 5.8. But the very last problem I did in 5.8, I put up a problem something like this. And the reason I did that was I put this problem up and we set it to 0. But the problem is x squared breaks up x times x. Signs are the same, both plus. There's no two factors of 7 that adds to give you 2. So that won't factor. And so I told you, I said, the section 5.8, solving quadratic equations, I said that's called solving quadratic equations by the factoring method. The whole crunch to every bit of that is it has to be factorable in order for you to do what we did in 5.8. And so I went on and I said this. Well, what if you can't factor it? Then you can't solve it by factoring. But then I went on and said this. Does that mean that it doesn't have a solution? Does that mean it's no solution? No. This problem right here still has 2 answers. You just can't solve it by the factoring technique because it won't factor. Same way with this. X squared plus 11 equals 0. Is this a quadratic equation? Certainly is. Is it a second degree equation? Yes. Does it have 2 answers? Yes. Why can't I solve it by factoring? Because x squared plus 11 is a binomial. And remember how do binomials factor? GCF, there's not one. A difference of 2 perfect squares, it's not. Or cubes. This is certainly not cubes. So this problem is prime. And so both of these problems are quadratic equations. Both of them are solvable. Both of them have 2 solutions. But they're not solvable by the factoring technique that we learned in 5.8. And I believe I mentioned this then, but it's okay if I didn't. It turns out that there are 4 methods to solving quadratic equations. The reason you have to have multiple methods is sometimes you run into one that doesn't work, particularly the ones we do in here. So there's ultimately 4 methods to solving quadratic equations. In this course, we do 2 of the 4. When you get to college algebra, at the very beginning of college algebra, we do the other 2 methods. So we only limit our discussion to solving quadratic equations by 2 methods. The factoring method, which is limited because not everything factors, and also by the method that I want to talk about with you in this section. So write this down, solving quadratic equations by the square root property. So write that down right there. Pause the video if you need to. Okay, so when we finish this section, we will have covered in this course 2 ways to solve quadratic equations. The factoring method, if it can be factored, and this square root property. All right, so before I give this, before we do problems like this, I need to give you a note and then I'll give you the steps. Here's the reason I need to give you a note. Like the factoring method, the square root property won't work every time. For instance, this problem right here, you'll see why in a minute. Could this one be factored? No. It turns out you can't do the square root property on that one either. But you can this one. So the square root property is still limited in that it doesn't solve all of them. So I need to know two things then. Number one, I need to know when will this method work. And then number two, if it will work, then how do I use it? So let me give you the first note on when you can tell the square root property is usable. When is it in play? All right, so take this note down. You may need to pause the video as I read the note. Here's the note. The square root property solves quadratic equations that contains exactly two terms. Those two terms must be the squared term and constant term. Okay, so let me restate that again. So the square root property, when you use it, there can only be two terms in the problem. What are the two terms? It's going to be the squared term, you're going to have an equal, and you're going to have a number term. That's what it's going to look like. Now, they don't have to be on opposite sides, but there'll be two terms, your squared term and a number term. Like right here, squared term and a number term. But right here, squared term, number term, but you have an extra term. So you will never use the square root property when you have the three terms in the problem. You'll only have two. One will be your squared, and the other must be your constant. Has no x with it at all. So here's what I want to do first. I want to give you a few visuals on what they look like. Now, we're not going to work these yet, but look at these problems right here. Here's 5 problems. You don't have to write these down, but do look at them. These 5 problems, all 5 of these problems, they have several things in common. Number 1, they're all equations. Number 2, they're all quadratic equations. What's a quadratic equation? It's a second degree polynomial equation. But here's the third thing they have in common. All 5 of these problems have only 2 terms in it. One of them is your constant term. Constant, 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 constant. The other one is your squared term. Squared term, squared term, squared term, squared term. Now notice I said squared term. I didn't say x squared term. So it may not be just the x squared. It may be some x stuff squared. But still, this is 2 terms, 2 terms, 2 terms, 2 terms, and 2 terms. So you can use the square root property on any quadratic equation that has 2 terms, one of which will be your squared term, and the second one will be your constant term. All right. Now, let me give you the steps. Write these instructions. Title this note. Write this out in your notebook right now. Title the note, Steps in Using the Square Root Property. Steps in using the square root property. Step 1. Pause the video if you need to. Step 1. Isolate the squared term on one side and constant on the other. Step 2. Take the square root of each side and introduce the plus minus symbol. And that plus minus symbol looks like this. And introduce the plus minus symbol. And then step 3, solve for the two solutions. Solve for the two solutions. Okay, so the instructions here, solve by the square root property. Solve by the square root property. And write this one down. X squared minus 16 equals 0. Now, before I solve this one by the square root property, and I picked this one because I want to show you something. This one actually could be solved by the factoring method. Let me just show you that. Don't write this down. How do we solve it by the factoring method? First, it has to be set to 0. It is. Secondly, factor this. Okay, it's a binomial. There's no GCF. So the only two things it can be if it factors is either squares or cubes. Is this the difference? Yes. Of 2? Yes. Perfect square? Yes. So this is the difference of two perfect squares. So x squared is x times x. 16 is 4 times 4. This means the signs are different. Now take and set both of these equal to 0. And then subtract 4 from both sides to get my first answer. Add 4 to both sides to get my second answer, which I knew would be the case because it's a quadratic equation. So this one could be solved by the factoring method. Now, I want us to solve it by the square root property. So let's do that. All right, step 1 on the square root property. Isolate the squared term. Is the squared term right by itself? No. So what you want to do is you want to get your squared term on one side, number term over on the other. So add 16 to both sides to get that squared term on a side by itself. So that's step 1. Step 2. Take the square root of each side. Now, why do we do that? Well, let me run a little bit of a rabbit right quick with you. Let's suppose I take 5 and I square it. All right, so you tell me, what is 5 squared? That's 25. Now, if I turn right back around and take the square root of it, 5 squared is 25, but the square root of 25 is 5. So, when you take the square root of something squared, what does it do? It just gives you what's being squared. As a matter of fact, you learned in the last section that goes both ways. Anytime you take the square root of something and you square it. So see, those two things are interchangeable. So a square root will undo a square, and a square will undo a square root. So when you take the square root of x squared, you just get x. Now this is the part that you have to remember about step 2. Step 2 says take the square root of each side, but that's not all step 2 says do. It says, and introduce the plus minus symbol. Now let me explain why. When you take the square root of 16, why is it plus and minus 4? Because what is 4 times 4? It's 16. But what is negative 4 times negative 4? Isn't negative 4 times negative 4 16 also? So see, the square root of 16 really has two answers. A positive 4 and a negative 4. So there's two answers there. Now, a lot of students forget that plus or minus. So let me tell you a couple of things that might help you remember it. First of all, remember a quadratic equation always has two answers. So you should have two solutions. Now, when you enter these solutions, I think you can enter it like 4, negative 4, 4. Don't put parentheses around them. Or I think there is the plus minus symbol on your button pad. If you go to that template where you use your symbols, I think there's a plus minus. It may let you enter it that way. But you can enter it either way. But on every one of these, you're going to have a plus and a minus answer when you do that step 2. Now let me make one other comment, and I hope this don't confuse you, but I want to make a point. You say, well, Mr. Rayner, all those problems that we did in chapter 7, we had square roots all over the place. We did. But we didn't put any plus or minus. That's true. So earlier in the last chapter, when I asked you what is the square root of 16, we said 4. We didn't put the plus or minus. And you say, okay, now I really am confused. Why didn't we put the plus or minus before, but now all of a sudden we are putting the plus or minus? Here's the difference in the two. In mathematics, there's 2 kinds of square roots. The first kind of square root is what we call a principal square root. And here's what that means. A principal square root is a square root that is already on the page for you. For instance, you will remember in chapter 7, 7.1, we did problems like this. I said, what's the square root of 25? And you said 5. We said, what's the square root of 36? And you said 6. And we said, what's the square root of negative 49? And remember, if there was a negative in front, it just made your answer negative. All of these were principal square roots. In other words, all of these, the square root was already on the page for you. Now, in the problem that we just worked, here was the original problem. Do you see a square root anywhere in this problem? No. So there is no principal square root in this problem. Now, there's a square root that pops up right here, but I put that square root in there. Anytime you take the square root of both sides, you have to consider the positive and the negative answer to it. Always. So I don't want you to go back into the last chapter and put plus or minus in front of all of it. They're not supposed to be, because the radicals were already there. But in every one of these problems where we put the square root ourselves, we're going to have to put the plus or minus every single time. Now, let me remind you of one other thing before we go to the next examples. Remember, if there was a negative under here, that's where that I comes from. Even if you can't get the square root of that number, like this, square root of negative 11, there'll still be an I in your answer, but you can't get the square root of 11. So you would leave it under there. Now, you could write it this way, I square root of 11. Now, if I could reduce that, I would reduce it, but it won't. But remember, a negative in front just makes the answer negative. A negative under the square root is where the I comes from. Okay, so we have solved one quadratic equation by the square root property. What we will do to complete this section and this course is we're going to do 4 or 5 other examples on solving quadratic equations. So for this next video, by the square root property. So for this next video, you're still going to be using those same steps, solving quadratic equations by the square root property, but you can only use this method when your quadratic equation contains 2 terms, and those 2 terms must be the squared term and constant term only. So this concludes section 8.1 video, part 1.